In the following video, we're going to examine the special cases on solving a system of equations. Remember, when we were graphing system of equations, we actually had three possible answers. You can actually get a solution of x and y. You can get a point where the two graphs intersect. And we saw in the previous videos, the same goes with substitution method and elimination method. You can get a value for x and y. You can get a point of intersection. But we also learned that there are the solutions of no solution. Graphically, that represents the two lines not intersecting. That represents the two lines being parallel to each other. Or we knew that there could be one that they always intersect. There's infinite solutions, so the two lines are the exact same lines. Well, we also have those special cases when it comes to solving system equations algebraically, either elimination or substitution method. So what we're going to do is we're going to look at what this looks like in both cases. So in this technique, on the first example, 5x plus 6y equals 45 and negative 5x minus 6y equals 38, I'm going to use the elimination method. I see I have an opposite here, 5x and negative 5x, so I don't need to create them. I can just add the two equations together. And what's going to happen, you would see 5x and negative 5x cancels. So now if I look, I have 6y and negative 6y, that cancels. So I'm left with 0. And then I have 45 and 38, which is going to give me 83. So if I look at the statement, it says 0 equals 83. There is no way for 0 to equal to 83. They are different. No matter how hard you try, 0 will never, never, never equal 83. And so since it will never equal 83, you can think of it like 0 will never equal 83. The lines will never intersect. And so that means this is an example of a no solution. So a false statement means the lines will never intersect each other. So it's a no solution example. If I were to look at this example, 2x plus 3y equals 5 and 6x plus 9y equals 15, I'm going to multiply the top equation by negative 3. And that's going to make the top equation now negative 6x minus 9y equals negative 15. And the bottom equation, I have 6x plus 9y equals 15. I have my opposites. I can cancel out my negative 6, so let me add these two together. Negative 6x plus 6x gives me 0, so those cancel. Now I have negative 9y plus 9y, which is 0. And so I have 0 on the bottom. Negative 15 plus 15 is 0. That's true. 0 always will equal 0. And it's kind of like the lines will always intersect. It's the same equation. So then every single point of intersection is on the line. So we say this is an example of an infinite solution. So we know that a true statement means that we have infinite solutions because the numbers will always be equal to each other, so the lines will always intersect. And a false statement is going to be an example of a no solution. Now the same thing is going to happen if you were going to do the substitution method as well. It's going to be a different process to get there. But even when you're doing the substitution method, you'll end up with either, for a special case scenario, a true statement or a false statement, and it's going to mean the same exact thing. So this technique of false statement being no solution and true statement being infinite solution, though I'm only using the elimination method approach in both these examples, it applies as well to the substitution method approach.